Good afternoon, viewers. This is Chandana Kumari, Assistant Professor from Department of CSC in Mlritm College. And today I am into the subject of programming through problem solving. In it, we will go with the topic of critical thinking on prime numbers. Before going to the critical thinking, let's see what is computer and the myths and facts on the computer. Computer is an electronic device, as we all know, and it takes inputs and displays outputs. This is the common definition for a computer. And apart from that, the myth is that computer can do everything by its own. But actually, the fact is, computer cannot think by itself or make decisions by itself. In fact, it is always dependent on the user. And a programmer should give the inputs properly and logic properly, and then only computer gives you the outputs. So here relates with the critical thinking part. As the computer cannot think itself, a human or the user or the programmer should give the inputs properly through the critical thinking session. So let's see what is critical thinking. Critical thinking is a process of approaching a problem in systematic manner, creating the solutions such that it can be carried out by the computer. That means computer should work on the commands given by the user. Now, why is it important? As such, every problem may have multiple solutions. So, the critical thinking leads in such a way that every problem can have multiple solutions, and what are the different solutions through which we can solve the given problem. And by this, we become problem solvers instead of software technicians. Let's go with an example on critical thinking, where we will take an example of whether a number is prime or not. Now, on this scenario, whenever a question is given, that is, a problem is given, the analysis to be done in three areas. That is, what is the input given, what output the program will give, and what is the logic behind it. As such, we think the logics by ourselves. Now, whatever the logic we think, we have to give it in a proper procedure to the computer. Now, in this question of prime number or not, the input is I will be giving a value, and the computer should give an output saying that given number is prime or given number is not a prime. So the input which we give, we can give it in two ways. That is, either we give the input from the keyboard or input will be initialized. These are the two ways we give the input. So as of now, we are clear with what input to be given, what output we get. Now pitching into the critical thinking part, that is the logic session. We all know that as per the definition of prime numbers, one is neither prime nor composite. This is first point we know as per the definition. And a number which is divisible by 1 and itself is a prime number. Taking these two concepts, let's first start with the second part. That is, whenever a number is given, we say that it is prime because it is divisible by 1 and itself. Let's take this example, 13. 13 is divisible by 1 and itself. That means we are also telling internally that no other number in between 1 and 13 should be divisible. And once it is divisible means the remainder should be equal to 0. So here the remainders are 0, and in between it is not divisible means the remainders are something else apart from 0. Let's go to the first logic part. One is neither prime nor composite. Now, we shall justify why one is not a prime. Now, as per the definition, given number should be divisible by 1 and itself. Now, here 1 and itself both are only 1. So, it will be divisible and remainder is 0 means you will be getting only once this situation. So, 1 is not a prime number, and any number which is divisible more than once is also not a prime number. Okay. Now these two are the major logics we have to take into consideration. Let's see the next part of it. I have to give a number as an input. So the number, let's say the number be n. Now the critical thinking part, next process is that which topic of our C programming suits to solve this problem. And we should also count how many times a number is divisible. So how many times a number should be divisible? It should only be divisible by 2 times. So the count should always be 2 itself, not more than 2, right? See here, see the below examples. Number 3, it's divisible by 1 and itself. So the count will be 2. 5, divisible by 1 and itself. Count is 2. 11, count is 2. Now when you take for 6, what is the count? Count is 4. So the logic here is count is 2 only leads to number is prime. If count is less than 2 or greater than 2, it is not a prime. Okay, let's see the next part. Let's code now. I have taken a number. Let me see that this is the number. Now how to check? From 1 to n, with all the numbers I should do my division part, right? How will I do the division and get the remainder as 0 in C programming? That means I should use modulo division to get the remainder. So remainder to be 0, that is why we will be using modulo division, which is an arithmetic operator. And then every value here is an increment of the previous value. That means first value is 1, second value is 2, so on, it's going on. So the difference between every value is only 1, constant difference. And my starting number is 1, my ending number is n. And there is a change in every time when you are doing the division part. That is, the number is getting changed. So I can use for loop for this, because for loop has 3 categories, that is initialization, then I will be having condition, then I will be having increment or decrement. So what is the increment or decrement here? Increment only will be done, that is plus plus. What is the condition here? My number should be always, the checking number should always be less than n. Okay, and also equal to n. Then what is the initial value? It will start from number 1. This is number 1. It will start from 1. It will end till n. And every time there is an increment of 1 value every time. So it is plus plus. Taking all these 3 conditions, I am clear that I should use modulo division symbol. I should use a for loop. And also I should use if else statement to give the output. That is, whether it is prime or not. We'll see the code. If my number is n and I am taking an variable I, where this I gets changed from 1 to n. Okay. So every time I will be doing modulo division by I and my remainder should be 0. This is my actual condition which is to be done. Then what I have to do? I should count. So if this is true case, that means my number is divisible by I, and if it is equal to 0, then I have to count how many times it is done. So I am putting a variable as C and T, and this C and T will be always being incremented. This is the internal actual logic what we have to do. Then this I starts from, as I told in the previous slide, I starts from 1 to n. So I have to start my for loop. Let's see the for loop. I have defined int I is equal to 1. I is less than or equal to n and I plus plus. Why is it less than or equal to n? Because I have to check from 1 to n. With all the numbers, I have to check my given number. So it is equal to. If I write I less than n, so it stops. That means the rotation the loop will be stopping only till n minus 1 values. That means I will not be calculating till the given value, which is not actually the rule of my prime number. So to justify the rule of the prime number, I have to take I is less than or equal to n, right? Next, if n is less than or equal to 1, that means input whichever I have given, if it is less than 1 or equal to 1, is it a prime? No. So to tell this, I am writing above as if n is less than or equal to 1, please print it is not a prime automatically. Don't check the condition, just print it is not a prime. If not, that is else part, do this all steps. Am I clear? Let's go to the next part. After all the checking happened, that means after the rule gets, after the loop gets turned out many times and you get I value greater than n, because I have written less than or equal to n, more than n when I gets, I will not be moving into this for loop. Then I have to check how many times the count has come, because every time I was incrementing my count, I will be checking how many times I got the count. If count is equal to 2, print it is a prime, else print it is not a prime. This is actually the critical thinking part and the logic part behind checking whether a given number is prime or not. Let's add the above part for it. That means the programmatical above part as per the C structure. Now see, this is the final program. I have started with hash include stdio.h, my main function, and see I have directly defined n value to be 29. That means what is this n is 29? This is initialization. I did not give the value from the keyboard. Okay, let's see with the next example giving the value with the keyboard. As of now, n is 29. That means I have defined the value of n to be 29. And what at the initial stage, my count will be equal to 0, and every time in the loop, count gets incremented. Apart from this, these 4 lines, all others are what we explained previously. Okay. And because I have written int main, I am writing return 0. Okay. Let's trace the program. Now, first time my n is 29 and count is 0, fine. And because my n value is 29 and it is not less than or equal to 1, so I will not be moving into if loop. Okay, I will not be moving into if loop. I will go into else loop. Okay, and inside this, first time my I value is 1 and I will be checking the condition 1 is less than or equal to n. That means 1 is less than or equal to 29. Yes, condition is true. When condition is true, I will be going inside the for loop. So when I go inside the for loop, I am telling as 29 percentile 1 is equal to 0. Yes, this is equal to 0. So my count got incremented. As my count got incremented, now the value of count is 1, because earlier the count is 0, now the count is 1. Then what happens? I gets incremented, I plus plus. Now my I value is 2. 2 is less than or equal to n. Yes, condition satisfied. Goes into the loop. But here what happens? 29 percentile 2. Is it equal to 0? No, it's not equal to 0. When it is not equal to 0, my count will not increment. So my count is as it is like the previous count. Okay. Then this happens. That means the I plus plus will go on rotating for I is equal to 3, 4, 5, 6, so on till less than or equal to, so till 29. Okay. But what happens when it comes till 29? What happens? It gets satisfied with 29. Okay. So here the count gets incremented again and it becomes 2. in between, nowhere the count gets incremented. As count is equal to 2, the value will be, that means the printf statement will be printed as the number is prime. As I wrote percentile D, so 29 is prime will be your output. I have mentioned n here, this is percentile D related to it. So 29 is prime. From where did you get 29? My n value I gave 29, so 29 is a prime. If it was not, it would have printed else part, and this will be your close of the program. Let's see the output. Same logic I have written. Now see here, I have closed my else loop from here to here. Okay, and I got 29 is a prime. This was my output. I am satisfied, I got it. Now there may be a situation, your thoughts may be, this else part when it is getting executed, every time when I do the else part, why can't I write this if statement inside the else part? That means if count is equal to 2, if I write inside the else, that means this whole part if I write inside the else and I change my flower bracket here, that means close of my else if I change it here, what happens? As it is a for loop, so every time the I gets incremented, every time the count will be checked, and every time it will be printing as it is a prime. So multiple times you will get the output as prime. Let's see that output also. I have opened my else here. I have closed my else here. Okay. Because of this, and the for loop got incremented every time. As many times the for loop got incremented, it was printing 29 is a prime, 29 is a prime. So it would print 29 times saying that 29 is a prime. So proper placing of brackets for the for loops is also very much mandatory. Okay. Let's see a scenario based question on this prime number. Let's read the question. In a university, a class teacher wants to group up students into 2 groups. Okay. Each student roll number is to be determined as a prime or not. Class teacher also wants to check whether the student is entering himself positive integer as his roll number or not. That means the teacher has asked every student to come and enter his roll number, his or her roll number, and the teacher also wants the code to be executed in such a way that if it is a negative number, the output should be it's a negative number. If it's a positive number, then it should check whether it is a prime or not. So taking all this, the teacher has mentioned the test cases. There are 5 test cases given here. If the input is 2, it should be printed prime, 17 prime, 8 it is not a prime, -5 invalid input, -20 invalid input. Now here in this scenario, the inputs are getting changed every time. So I cannot initialize my value to be n is equal to 29 like the previous program, right? I have to give the value of n from the keyboard itself. Okay. That means I have to improvise my code in such a way that it would be executed for the given inputs and my expected output would be the actual output. Let's see what changes would happen and where we have to do the changes. All the green marked areas are the changes. Let's see one by one. My int n, I am giving n value itself. Only one value at a time I will be giving. So, because my teacher was telling, as per the scenario based question, teacher was telling that every student would come and enter their roll number. So one by one student would be coming. So every time the n value gets changed. And at a time only one student can give the input. So taking that, int n, only one value will be given as input. Because the input is not a fixed input, I am writing printf enter the value as the input and scanf %d %n, which leads to taking the input from the keyboard. So every time I change the value, it goes on as the input for the n, and the process, that means next steps will be continued. Now see here, our question was, if it is these two cases when we take, if it is less than 0, how would I know that those numbers are, that means the entered value by the student is negative or positive? It is only known all the positive numbers are above 0, right? All the positive numbers will always be above 0 and all the negative numbers will be left side to the 0. So I will be taking 0 as the midpoint and I will compare that whether the given number is lesser than 0 or greater than 0. If it is lesser than 0, I would be telling invalid input. If it is greater than 0, I have to check with all the conditions of prime or not. So that case I have taken, if n is less than 0, print invalid number. Because of this line, these two test cases would pass positively. That means for these two test cases, that code would be helpful. And apart from that, else I will be doing all the logic, okay, same as like the previous what we have seen. And there is a slight change. My expected output is always either telling not a prime or a prime, that's all. It's not printing the value like our previous example. So taking this consideration, I have changed my printf statement, in the printf statement, prime or not a prime, that's it. If it was asked to print the value, then we would be writing as %d, so on, all the cases, all the steps like what we have done previously. So these are the areas, all the green areas we have to change with our program for the scenario which has been given. Now let's trace for the scenario also. Our first case was 2, 17, 8, minus 5, minus 20. Okay, 2, 17, 8, minus 5, minus 20. Let's take them. 2, 17, 8, minus 5, minus 20. Now when n value is 2, n value is 2 given from the keyboard. N is less than 2? No, n is not less than 2. So it would not print as invalid input. It would be going to the else part and checking all the conditions. Now here when it checks all the conditions, your n is 2 percentile, I value first time would be 1, which is equal to 0, and your count got incremented by 1 and count value is 1. Next I gets incremented. So 2 will become, same 2 value will be done modulo division with 2 because I is changed. Here also you will get 0. So my count value will be 2 here, right? Next, I plus plus. I will become 3 now. Let's check the condition. 3 is less than or equal to n? No. When it is no, this loop will not be working out. So automatically count is 2. Next step will be executed, that is count is 2 and printed as prime number, prime. Same thing happens for 17, same thing happens for 8, right? And when you go for minus 5 and minus 20, n values are less than 0. So your output would be invalid input. When it is invalid input, your else part will not be executed. Hope we have completed. For all the given inputs are expected outputs. Based on the input and the expected output, the scenario based question should be solved. The main challenges students face is that they would never check what is the expected output. They blindly go with whatever they have learnt with their printf statement. because printf statement has percentile d, so on. So they are tuned up to percentile d concepts. There are two types of printf statements. Either you print a value or you print a statement. If it is a print a value only, you will go for this format specifiers writing and printing the value. Else, you will be just mentioning the statement, whatever the statement to be filled in double quotes directly, and which will be helpful for your expected output properly. And sometimes the expected output has two lines of output. In that scenario also, be cautious while writing your printf statements. In the next class, we will be seeing about prime numbers till a given limit. So that means I wanted prime numbers from 1 to n. Between, I want all the prime numbers to be printed. In the next class, we shall go with that concept. And these are the references which would help you for detailed critical thinking of every program or every concept in your C programming. And this would also help you for going to your scenario based questions. And I have used ProgramWiz for executing the program and displaying on the screen now. Thank you all.